three resistors connected across A and B, and these wires, they are perfectly conducting wires. When we say perfectly conducting wires, that is resistance is equal to 0, and once again it is an assumption only. All the conductors, they have some resistance, and all the resistors, they have some conductivity. For ease of understanding the concepts, we are taking these wires as perfectly conducting wires. So over here we have to find the equivalent resistance between A and B. So what we see over here is a neatly drawn diagram where the wires, they are nicely arranged, whereas in practice these networks may look like this. So over here, when we say these are the wires, so obviously they are the flexible wires. So instead of a sharp bend over here, we can give a slight turn over here. So obviously when we do it like this, we have not disturbed the actual configuration of, that is the resistance, that is equivalent resistance between A and B. We have not altered the equivalent resistance between A and B. So over here also, and we can make it over here at all this thing, we can make it like this. Now if this wire over here, this is junction, this wire attached to this, whether you attach to this or you slightly attach to this is one and the same thing. You have not made any difference because you are sliding only over the conducting wire only. You connect it over here, you connect it over here, or you connect it over here, that is one and the same thing. If you connect it over here or you slide slightly more, or you slide to this point, that is once again the same thing. You are sliding only on the conducting wire only. That is, or you connect to over this point, or you can connect to this point, it is one and the same thing. We have not done any changes. Or you can also connect it over here, that is still there is no change. Or you can connect to this point, it is still there is no change. You are sliding this wire only on a pure conductor only. So you have still not changed any configuration. You have still not changed any equivalent resistance between A and B. The arrangement of the resistors is still same. Whether it is like this or it is like, it is one same thing, or it is like this, it's one same thing. So what we can do is, this wire which is taking this shape, we can just stretch it, we can pull it and make it straight, and we can slightly pull it over here. So instead of it goes like this, we pull it over here and let's say make it over here. So this wire comes over here, and obviously this goes off. So whether we put a resistance over here or here or here, that is one and the same thing. That is, instead of R over here, we can remove it, and we can slide over here. That's one and the same thing on one wire only. On this only we are shifting. We can shift anywhere. We are not jumping any junction or so. Over here, this is some extra wire. We can save some wire, let's say by shortening it, and instead of going like this, we can also make it like this. That is, still we have not made any difference. We have not changed the configuration of the resistances. As we have done over here, similarly, we can connect, instead of here, we can connect it to this point. We can connect it here. We can connect it here. We can connect it here. We can slide further. We can connect it here. We can connect here also. This is a wire. This is end B. We can pull the wire, we can stretch the wire, and we can take B over here. So when we take B over here, so B comes over here, this wire is stretched and moved to this point. So as a result, now this goes off because this wire only, it has shifted over here. Now R is here, whether you put R over here, whether you put R over here, or whether you put R over here, it's one and the same thing. We have moved from here to here to here to here. This is one and the same thing. This is some extra wire. What we can do is, instead of wasting so much wire over here, we can directly connect it like this. We can shorten it and we can save some wire. So now what do we see? We see between A and B, all these three resistances, they are in parallel. So 1 by R equivalent is equal to 1 by R plus 1 by R plus 1 by R is equal to 3 by R. So R equivalent is going to be R by 3. So from here we understand that is we can slide one wire over the conductor, but we cannot jump any circuit element.